On the summary output that Excel gives you when you do regression analysis, you'll see that there's a bunch of things that are listed as R in the corner. There's multiple R, R square, and adjusted R square. And each one of those has its own unique function in determining the relationship between your predictor variable and your outcome or response variable. R by itself, or multiple R, as Excel says, is just a measure of the strength of the relationship and also the direction. So if your R is +1, that means that for every unit of X increase that you have, every additional unit of your predictor variable, your response variable is going to increase proportionally to that. So if you have a perfect variable cost and you know, like you're just buying goods from somebody and they cost $5 a piece, the relationship between number of units purchased and the total cost of your purchase, since each additional unit is $5, will be one. It's a perfectly positive correlation between the two. If you get a negative number, that's the opposite. That means that as X goes up, Y goes down. And there's not really cost isn't a thing where they usually go down the higher quantity you have, but there are other elements that cost accountants can work with. Like the more and more your workers do stuff, the faster and faster they get at it. So units produced and times to produce a unit might have a negative relationship. And then if there's a zero in the middle, that means there's no correlation whatsoever between the two. So on our summary output, going back one more time, we had a pretty strong multiple R and it was positive. Our relationship again is the number of calls increasing the total cost of our call center. Well, that R of 0.83 means that there is a strong relationship between the two, that additional calls, because it's positive, increases our total cost, which makes sense, but it doesn't capture everything. There's other factors besides that that are causing the call center's total cost to change on top of the number of calls they field. R squared is a better measure in this case of determining how good using that formula as your predictor will fit actual outputs to that line. And as I talked about on the last video, we have an R squared of 0.69 rounded off. Means that about 69% of the increase that we have in total cost is caused by the call center, fielding additional calls. And that's a good chunk of it, but it's not all of it. So we know we won't be a perfect predictor in this case, but it will be a strong predictor. Maybe we want some other variables in there. Maybe we want to figure out other things that could influence the cost of the call center. I mean, we gotta, you know, heat and cool the call center in the winter and summer, respectively. Maybe utility costs in the place there, based upon the temperature, would change our thing. We want to have a temperature variable that we could use. Maybe the experience of the people that are working in the call center would be something that would, change the cost. They're better at handling customer support calls in a more timely manner than a newbie, if you will. There's a lot of variables that can come in, and each variable will have its own R squared. Like each variable will cause a certain portion of the relationship to strengthen, which is a bit problematic if you use a bunch of different predictor variables. Because if you use multiple different predictor variables in there, they're cumulative, which means the R of variable one will get added, sorry, the R squared of variable one will get added to the R squared of two, R squared of variable three, etc. And eventually you'll have a spot where you're like more than 100% of the relationship or more than 100% of the change can be explained by the relationship between the predictor variables and the total cost of the call center. Well, that it isn't possible. You can't have more than 100%. To account for how good a relationship is going to be when you're using more than one thing as a predictor variable, you want to use the adjusted R squared. It is a goodness of fit measure when you have a lot of independent variables in or predictor variables in your regression model. It basically assigns a small penalty for each additional one that you went in there. So you know about if adding another variable will make your new model a better predictor or a worse predictor. So here is the regression line that we got when we did the summary output for the data that we have for the call center using all of the inputs. Before we did the high-low method, where we only took the high and the low. Now we're taking into consideration all of the different months of data that we have. And as you can see, that line, our regression line, is a much better fit to the lines of actual data than we had before. It seems that using all of the months in our information instead of just the high and the low month makes it a better predictor, which is always going to be true. The more data you have to work with, the better of a model you're going to build.